Now, I don't know about you, but I don't think this will fit on any of my 3D printers. So, how about we build a CNC machine instead? That's right, today we're going to be taking a look at the Milo V1.5 from Millenium Machines, and we're going to be building that CNC machine using this kit from LDOMotors. And I want to give a huge shout out to Jason and the LDOMotors team for providing this kit for testing and evaluation. If you want to source one of these yourself, this is an open source project, so you can self-source and build one of these. But if you do just want to get the kit like we have right here, I'll have a link in the description where you can find your local LDOMotors reseller so you can snag one of these for yourself. Now, we have dabbled with CNC on this channel in the past, and those familiar may recognize this ComGrow Robo CNC here that we've done a few projects with on the channel. But for those at home that are unfamiliar with CNC machining, let's go over some of the key differences between additive manufacturing and subtractive manufacturing. So first off, both of these are actually CNC machines. These are both computer numerical control machines. That means a computer is basically telling the machine to do whatever it tells it to do. The only difference is this makes chips, this splooges molten plastic. So similarities at the start are pretty common. They both have motors that move the tool head around in the X, Y, and Z direction. So on a CNC machine, you got our X motion, our Y motion, and the spindle moves up and down. And the electronics on a traditional 3D printer, a lot more simplified. On the lower end of a CNC, like a little home desktop router like this one here, you're gonna be seeing a lot of the same type of controllers. We're talking basic at mega driven things. This thing actually has a Duet 2 in it, running RepRap firmware. So there are some similarities on the lower end, but especially once you start going up to the higher end machines or you start getting more serious into CNC machining, the two platforms start diverging quite a bit. And we'll start right with the tool head. So on a 3D printer, we have our extruder motor. There's gearing involved. We're pushing plastic through a chunk of hot metal that's melting it, and we're laying down layers to build up the object we want. On a CNC machine, on the tool head, we have a big fat spindle. It is spinning at several thousand RPMs, and it's using a really sharp piece of metal to chip away metal, essentially, at a very rapid rate. So these both create the object you want through exactly the opposite means. A 3D printer adds filament until you get the object you want. A CNC machine subtracts material until you get the object you want. And of course, that's not the only difference. Work holding, for example, doesn't really exist on a 3D printer. We like to use PI flex plates nowadays. That's pretty common. Back in the good old days, we had Aquanet and blue tape, but essentially you're just printing onto the bed. It stays on the bed until the print's done and you pull it off. With a CNC machine, there's actually forces involved in creating the thing you want to make. You are putting force on your tool head. That's one of the reasons you don't see a lot of belts in CNC machines, at least the more professional rigid CNC machines, because you are pushing that cutter into the object you are taking material out of. So on CNC machines, you have things like vices, you have clamps. Some machines even have vacuums to suck your raw stock down to the bed itself and hold it in place while you machine. So at first, there are some similarities between the two, but as you get more into each specific category and as you get more serious in those specific categories, you will see a divergence. So now that educational lesson is out of the way, let's crack open these boxes and see what's included with the LDOMotors Milo V1.5 kit. So this kit does come with 2 boxes of parts. We'll talk about the 3D printed parts afterwards, but we'll start off with box 1 here and we'll go through and see what is fully included with this kit. So starting off, we got ourselves a list of all the parts, the bill of materials. That's going to be handy. And the first thing we have here appears to be a plastic. This is the bottom panel, I believe. And there are a few different configurations for this printer. The stock setup that is included with the LDO kit includes basically the machine is its own thing. So all the electronics are mounted to the CNC machine itself. There is also an optional enclosure that Millenium Machines is working on that has all the electronics for the CNC outside of the enclosure. So if you're doing something like flood cooling or whatnot, you're not gonna get your, you don't wanna get the magic pixies that power this angry. So if you're doing something like that, a separate electronics box, maybe something you want to look into, but we're going to be building this kit as it comes. So with the electronics mounted to the CNC, we've got these nice machine plates here. If I can get them out, there we go. So this kit does come with a few of the mods that are available for the Milo V1.5. And one of them is these machined brackets. This will give you a little bit extra Z travel along with much more rigidity. So you can bootstrap this machine by essentially using a lot of 3D printed parts and then replacing those with machine parts later on. But it is nice that this kit comes with some of those upgrades right off the bat. So we have those two plates there. Next we have some extrusions and rails. Now this being a CNC, we have XYZ travel, and I believe we got 2, 4, 6, yep. So we got 2 rails for each axis, and each rail has 2 carriages on them. So let's open one of these up to take a look. They do have the little stoppers on it to keep your carriage from going on a little adventure. And these appear to be, these are LDO branded rails, and they are SLR 15C and then 500 millimeters long. So these are the rails that are included with the kit. They seem pretty clean. Now I am gonna clean these and grease them all up before we start the build. Also in here, we do have some extrusions. We have these nice little plastic carriage holders. So if during the instructions to build this, it requires taking these carriages off, you do have a whole bunch of these little retainers here. So when you slide the carriage off, you can slide it onto here. You don't have to worry about losing your ball bearings. We have some extrusions here for the frame, and we have lead screws. Now, with CNC machines, since there are cutting forces involved, you want to have your travel as rigid as possible. You don't want banding, you don't want it to be bouncing all over the place. So instead of belts like you would see on a 3D printer, this kit uses lead screws. Now an upgrade from lead screws would be ball screws, but due to the design of this machine and cost considerations, it comes with lead screws. Now, if you are creative, I'm sure you could figure out a way to put some lead screws in this machine, but due to some other design choices, it is kind of limited. There's not really a ton of room where these go. So we have lead screws for travel, and then is that it? Yep, so these two flats here, this contains all the aluminum extrusions for the frame. A lot of it is C-channel extrusions. These are extrusions that LDO sources, and I've built plenty of LDO kits in the past, and they always have really good extrusion quality. So we have all this, and I believe this is all we would need for the frame. So this first box is relatively simple. It looks like it just contains the frame of the printer, some of the motion components, along with some panels. So I'm assuming the second box here is gonna have all the goodies to make this thing burr and make chips. So let's go ahead and grab the second box. So yeah, this box has the fun stuff in it. So we got some wrenches here, another bill of materials, some more paperwork. Also has the little plaque LDO likes to include for its serial numbers. So we have that. Got the Milo V1.5 cable kit. Look at all these cables, and like most LDO motor kits, they come pre-terminated, pre-cut to length. So if all goes well, you shouldn't have to do any crimping and stripping, hopefully. So that's gonna speed up a lot of this build. So there we go, that's good to see. And the boxes have this little list here that tells you what's included with the box, which is handy when you're hunting for something during the build. We have our hardware kit here. We've got some drag chains, zip ties, some tools we're gonna need. And this is all your screws, your bearings, your bushings, a little piece of DIN rail, some couplers, belts. Yeah, so this is all your hardware that you're gonna need to build the Milo V1.5. And again, this is an LDO kit. I know we're gonna say this a lot, but as previous builds have kind of shown me, LDO kits usually have pretty good quality components, especially things like screws. Next, we have the Long John kit here, and this is one of the optional upgrades for the Milo that LDO includes with their kit, and this is the tool setter. So this is basically, if you've built a Voron V2, you know how you have the separate Z switch for nozzle offset on a stock configuration. This is basically kind of the same thing. It is a switch that is used for setting your tool offset. So that's nice that that's included. Electronics, in here we have SD card, power switch, some ferrules, a good old, ooh, let me open this. I love big fat e-stops, so I want to see how good this click is. Ready? Ooh. I like this e-stop. So we got the e-stop, drivers, fans, expansion board, and some Wagos. So this is some of the electronics. I haven't seen a controller yet, so I'm assuming that's in a different box. Power supply, and this power supply is a Morrison LMF 350 24 volt power supply. So there we go there. Now these are the nice ones. These ones do auto switching, so you don't have to flip a little switch to switch it between 110 and 220, and they're nice and compact. So I've actually used this form factor in a few 3D printer builds. It's a nice power supply. We have the motor kit now. Now with the Milo V1.5, you can build it a few different ways. You can build it with NEMA 17s, which are the standard stepper motor you see in most 3D printers. But this kit includes, and it's optional if you self-source, NEMA 23s. So we got these big, chunky stepper motors here for the X, Y, and Z. They do all appear to be the same size. I don't see any specific callouts for which one's X, Y, or Z. So that's good to have there. And of course, they are LDOMotors steppers. And then we have our controller, which is a Mellow Fly CDY 6 version 3. So with CNC machines, you do have a few different options for controllers, and it really depends on your skill level and what you're looking to get out of your machine itself. So Gerbil is a common firmware you're going to see on like a lot of the 3018 entry-level desktop CNCs, but this one uses Wrapup firmware for its CNC, and I've dabbled with Wrapup firmware on CNCs, again the Comgrow Robo CNC that I have modded with the Duet 2. So Wrapup firmware is a decently capable firmware to run on your CNC machine, and it's especially friendly for those that are coming from a 3D printer background, because you may have already used Wrapup firmware. It's got a nice web interface so you can remotely monitor. You can change things really easily. If you got to make any updates, it's just a file you just edit and save, and it takes over any changes. There's no real flashing firmware if you want to make small changes. And yeah, you can upgrade to something like Linux CNC down the line, but it's nice that this kit comes with a controller that those coming from a 3D printing background are going to have some familiarity with. So we have that. Power cables here. So it does come with I do have a North American plug here, and I do have another plug here. I'm going to have to look into this. We're going to be talking about voltages later when we get to the spindle. We got some plugs. I've got, are these safety glasses? They are. Good old safety glasses. Again, this is a CNC machine. You're gonna be making chips. You're gonna have metal spinning at a few thousand RPMs. You're gonna wanna wear iPro when operating this thing. And let's be serious, you're probably gonna wanna put this in an enclosure as well. But it's nice that they include iPro. We have some extension covers here. I'm assuming this is for cable management or just putting in the extrusions or something. More cable management. Machined plates. What is in here? I'm assuming machined plates. We got, oh, this. Okay, so this is essentially your work surface. So this is optional, one of the optional upgrades that you can source from a few different vendors, but LDO includes it with the kit. So this mounts to your bed, and it's got a bunch of tapped holes in it, and this allows you to mount parts directly to the bed using clamps or fixtures or vices or whatever you want to mount to the bed. So this is a nice flat mounting surface. It's all nicely machined, nice finish on it. And then we do have some other metal plates here. I believe these are for the mounting the tool head with the spindle to the Z, and then also for the XY connection as well. So we do have some more machine plates there. Now remember, the stock setup for this build has a lot of 3D printed parts that in this kit are replaced with machine parts. So if you are looking for a more robust build of the Milo V1.5, you can either self-source machining these or machine them yourself if you have the ability to do that, or you can just buy the LDO kit and it comes with those. And then we have our spindle components. Now with the spindle, there's two parts here. The first one is the spindle itself, and this is a chonky boy. So what do we got to work with here? So we have a Yin Fan Jidiang, I guess. I don't know. I can barely speak English, so we'll go with that. And it's a GDZ ADF 1.5 spindle. So that's a 220 volt spindle, 1.5 kilowatts, 8 amp. And that's right, 220. I live in North America. If I plug something into the wall, it's 110. So how do we get 220? Well, luckily, my electrical panel is in my garage, and with the way North American wiring is actually set up, I actually do have 220. It just gets split into 110 at the panel in North American households. So, since the panel's right there and I could tap into essentially two of the splits, I could put a 220 volt outlet right there because the CNC is gonna live right here where the Tico is. So that is something I am going to have to do at some point, is install a 220 volt outlet in this garage so I can properly power the spindle. For the electronics, that works off normal 110. I don't gotta worry about it, but it's the spindle. Now you can source 110 spindles if you live in an area that uses 110 power. The downside of using a 110 spindle though is gonna be a lot less efficient, and you can't get as much power out of a 110 spindle than you can a 220 because of the amp rating. Normal household electrical wiring in North America, your average breaker is rated for 15 amps. This is a 220 spindle and it's already 8 amps. So at 110, you're dangerously close to that 15 amp and you're gonna have some efficiency losses. So this kit comes with 220 because it's not as easy to source a 110 spindle that meets the spec requirements for this machine. So you can do it, there are ones out there, but if you do want a 110 spindle at this time, you're gonna have to purchase this kit without the spindle and self-source your own compatible spindle. And with the Milo V1.5, there are provisions for 60mm spindles along with 80mm spindles, but also, again, this is an open source project, so you can, just modify what you need to do to put whatever spindle you want on it if you have the ability to do that. And a spindle by itself doesn't make chips, and we're gonna need something to actually drive this spindle. So think of it like a stepper motor, you have a driver. With a spindle like this, you have what's called a VFD. And this is the VFD that LDO includes, and this is a Shilin 1.5 kilowatt, 220 volt VFD. So this controls your spindle. And what the VFD does, it essentially takes the power from the wall and turns it into something that the spindle can actually use to spin and also control its RPM. So you have power coming in from the wall to this. You also have a control line coming into here from your controller. The controller tells this how fast to spin the spindle. This makes the spindle spin as fast as it's told to spin in very simple terms. So this is a nice little compact VFD for this kit. So that's good to see. And lastly, we have the Milo V1.5 CNC starter kit. So in here we have some goodies to get you started with CNCing. So you're gonna wanna buy collets, you're gonna wanna buy cutters, you're gonna need some tools, you're gonna need measuring equipment. There's a bunch of stuff you need to buy if you wanna get into CNC. But it's really nice that this kit includes some really nice newbie-friendly equipment that you're gonna want anyways, like 1, 2, 3 blocks. If you don't know what a 1, 2, 3 block is, you're gonna get to know what 1, 2, 3 block is if you start getting into machining. We have some collets that come with it. There is one in the spindle already. It's a, what is that, a 6.5 collet? 6.5 collet, and these are ER16 collets, by the way. We also have included a 3mm collet and a 6mm collet. We have some dowels, some shims, some cutters, end mills, a magnetic stand, a nice little magnetic stand here, and also, oh, this is nice, that they included, we have ourselves a dial test indicator. There we go, nice little squiggly. If you've watched this channel in the past, or if you watch this in the future while I'm doing CNC stuff, I'm gonna refer to this as an interrapid, simply for the fact that the tool shop I used to work in, everyone referred to them as interrapids because that's like a name brand. That's like a Q-tip. Calling a cotton swab a Q-tip, calling one of these an interrapid is just part of the lingo in my area in tool shops. So I call these interrapids. But we do have this. This is really nice. I believe this is in metric. Yep, this is in metric. So for me, that's gonna take some getting used to because I'm used to manual machining on Bridgeports and lathes and grinders where everything was inch standard. All the machines were inches, so I worked in thous. So me switching over to machining in millimeters is probably gonna take me some getting used to. Now, if you don't know how to use these tools, I'm not gonna go into it in today's video because each one of these deserves a class on its own, but you're gonna be using these a lot for tool setup, for part setup, and for verifying what you machine is good to go. So it is really nice that they include some of these tools to get you started. In fact, I believe you have pretty much everything you would need to do some pretty basic CNCing without having to go and purchase any additional tools. Now, you're probably gonna wanna get yourself a set of calipers, some micrometers. It depends how serious you wanna get. You could spend a lot of money on measuring tools and setup tools. If you get into CNCing, it really depends what you're looking to get out of this and what you're planning to do. So it's nice that they include a lot of the basics, but you're still probably gonna go out and have to do some shopping if you're serious about getting into CNC machining. And that appears to be everything that's included with this kit, except the printed parts. So let's get those out. So we have our 3D printed parts here, and the Millenium Machines team have stated they've taken a lot of inspiration from Voron design in both design aesthetics and manual. And part of that is there are 3D printed parts involved with this CNC build. And they do recommend you print all the parts in ABS or ASA with essentially Voron spec settings, although a lot of the more robust parts like motor mounts and spindle mounts, you're gonna wanna print with actually more walls even then. So these parts there's not a lot of parts here, but they're very dense. So you're gonna wanna budget at least 2 kilograms of plastic for this, plus another kilogram for accent parts, because these parts are actually kind of heavy. And I've gone ahead and printed everything in ABS or ASA, although there are some exceptions. So let me get those parts out here. The spindle mount and the X motor mount is printed in this Filaments CA carbon fiber polycarbonate copolyester filament. I've had this for a while. I wanted to give it a try. So that's what the spindle and the X motor mount are printed in. And then for the Y motor mount, that is printed in actually Polymaker polycarbonate. So it'll be interesting to see how these different materials hold up, if there's any advantages or disadvantages to using non-ABS. I went with the glass-filled and carbon fiber-filled plastics just for rigidity. And with how dense these parts are, I don't think we're gonna run into any issues. The only thing that you may have to worry about is potentially heat. Remember, this is a CNC machine. There's no heated bed, there's no hot end. The only things generating heat really are the spindle, the electronics, and the stepper motors. So this is essentially an open air machine as it comes stock before you enclose it. So you probably actually could get away with some of these parts in PLA. But you don't want to put your machine in a hot garage and it get, warm in the summer and you come out and your CNC machine's all droopy. So print with what they recommend unless you're okay with accepting that you may have to replace some parts if you decide to get adventurous with the plastic choices you go with. And of course, with the CNC machine, you're gonna be making a mess. So the last thing you're gonna need, along with all the components that we've shown here from the LDO kit and the 3D printed parts, is a place to put it. It's a CNC machine. It's gonna be loud. It's gonna make a big mess. It's gonna be a lot of chips involved, little bits of metal flying everywhere, or wood or plastic, depending on what you decide to machine. And you're probably not gonna wanna put this in your bedroom. So out here, I plan on putting it over here. I've got a lot of electrical, my panels there. I can put the 220 plug, and I'm probably gonna have to build or buy a really sturdy bench to mount this to. This is a CNC machine. Vibrations are gonna be a thing. This is gonna, if you put this on a wimpy desk, it's gonna shake it apart. So you're gonna wanna put this on a pretty beefy table. So that is everything we need. So we just got to go ahead and build the thing now. And to do that, we're going to do that on live streams. So starting tomorrow, tune in at 2 p.m. Eastern. I'll have it linked in the description below, and we'll start building this live. So I'll document the entire build process for this CNC machine during live streams. We'll do one a week until it is built. I did watch a live stream of 3D Maker Noob building his, and I believe it took about 10 hours to get his up and running, but he marathoned it. So I don't know, I'm budgeting 3 streams, maybe 4 to get it built, and then a stream of testing it and getting it online. So that is the plan. So if you want to watch the build series, make sure you are subscribed to the channel so you don't miss out on it. And of course, after it's all built and we do some testing on it, I'll do a follow-up video reviewing the entire build itself. So I hope you enjoyed this look at the LDOMotors Milo V1.5 CNC kit from Millenium Machines. And yeah, this is going to be a fun build. I'm looking forward to this. I had the chance to talk with the Millenium Machines team at Smurf last year. I did a little video on that. I'll have it linked in the description as well. And this has also been a project I've been following for over a year now. It's actually been quite a while I've been following the Millenium Machines project and the Milo development, and I can't wait to get this build started. So I will see you tomorrow for the build itself. Cheers.